There you go.
Maybe I didn't get that
Every time.
I missed that part, Mr. Graydon. You want it back? You want that on video?
Recording now?
Yeah.
Well, let's go then.
Okay.
All right. So lesson 31. We talked about symmetry. Now we're going to talk about reflections.
What? There's two?
There's three actually.
It's like a 7-page lesson.
Reflections. Same idea as symmetry, except it doesn't have to be the x-axis or y-axis. The question is, can you put a mirror somewhere and show the graph as being mirrored somewhere else?
Yes.
So instead of putting the mirror down the center of a graph and just one half looking like the other half, it's can you put a mirror somewhere and flip the entire image? Let's do this. If we have, let's say we have our x-y axes here. A little bit of a curvature, but that's okay. And most
Green.
we already have brown for the axes. Let's put
Blue.
green. Let's say we have a parabola that comes down and touches here and goes up like that.
That's possible.
Now, so use your brain here for a second. Is that parabola symmetrical?
Yes.
No.
Not along
Wait,
the
so what
x-axis.
Exactly. Well, that's part of the question. Is the parabola itself symmetrical?
Yes.
Yes.
Oh, yeah.
Yes.
Is it symmetrical about the x-axis?
No.
No.
Is it symmetrical about the y-axis?
No.
Okay, that's right. So the shape itself is symmetrical, but it is the axis of symmetry is right here. It's not the x-axis or the y-axis. So the answer to one of those questions would be no.
No, yes.
Well, when you say move 180, would that just be into the 180 quadrant, like the second quadrant?
Well, we're not. Let's just leave that alone for a second.
Okay.
Now,
Purple.
Orange.
let's say that this spot right here is about 5. Now, what happens if I took on my y-axis here? What if I put a mirror here?
Wait, what?
Let's put a mirror on the y-axis.
This is what Valerie was talking about.
This is probably what Valerie was talking about then.
Yeah, it is.
She's got 6 more minutes.
And put a parabola here.
Almost identical.
This almost did it. That means I'm improving. I have this parabola here.
One's a B, one's a U.
If I were to
Mirror.
pretend that I'm attached to a like a sheet of metal that has a hinge right here, and if we move that hinge over here, what we have done is reflected me about the y-axis.
So we're seeing the back of that.
Yes, that's why it's a different color. Whenever I write in green on the board, if you were on the back side of the board, you would see purple.
Whoa.
That makes
We
so
should
much
get one of
sense.
those mirrors.
Let's go on Mr. Petfield's office.
Wait, so the people that are watching us on the other side of the thing, it's like,
Oh, so the picture is
So Arena's hair is green.
we're being watched by the government, so that other room on the other side are government, people.
Okay.
Purple!
Okay, so on
So-
the inside.
So what we have done here is that this graph here,
Normal.
this graph here is a reflection about the x-axis of this graph. If we start with this graph and we pivot around the y, if we start with this graph and we pivot around the y-axis, we end up with this graph. Yeah.
Yep, got
This
it.
is hard with one hand.
Solid.
Get
So what happens here is let's say that this graph here, I wouldn't expect you to know this off the top of your head, but this one here is this shape right here. It's a
X squared.
No, I think it's not. Did you just do that in your mind?
I don't know.
Yeah?
Oh.
One over
Wait,
that. One over that.
no, not 1 over.
What you mean?
What you mean? What you mean?
What you mean?
What you saying?
Something like that.
No.
What happens? What happens if I multiply this out?
What happened?
X squared.
Plus
What was
25?
that?
Or minus 25?
Oh.
No, plus
And
25.
I said that trying to trap you because a lot of you try to do this in your head.
It would be
I can do it in my head, Some of you could probably do it in your head, but too many of you are trying to do it in your head and getting it wrong because you're not doing it correctly.
Plus 25.
Minus 10x plus 25.
I could do it.
I did it in my head.
I can't.
Like I said,
But
I
the other
can,
one's wrong.
some of you can, but not all of you can. And so if you are not one, and it's fine if you can't, okay? But if you can't, write it out. Show your steps so you don't keep getting those problems wrong. Okay, this one here, what happens if I multiply this one out?
X squared plus 10x plus 25.
That one's not right though.
It's
It's not the right formula for that. Because if it was 1, it would be on the other side at 16. 1 and 16.
What?
Or 36, sorry. What are you talking about?
So it'd be negative.
So 6, if it was 1 plus 5 squared, that would be 36. So it would be 1, 36. If it was 2, so it would be 2 and 49.
I'm not following you, and
Don't know what
I
you're
don't think I
saying.
want to.
You're wrong.
You guys are not that way.
You can plug that in as it is. I just want to say. So if it was 1 plus 5, that's 6. 6 squared is
It's changing colors.
Just for a second. Just for a second. Let's consider this.
Blue to purple
Uh,
to white
let's consider this instead of
Purple.
calling this y. Let's call this f of x.
to white to green.
Now, what would happen if I take this and if I plug in negative x?
Oh, look, when I scan onto his shirt,
Formulas.
when I scan onto his shirt, it goes way white.
It was.
Scan away from his shirt,
No, it was actually.
I was sorry.
scan onto his shirt. Scan away, it's like different
If
colors.
I plug in a negative x for the x, the 5's not going to change. Neither will negative 5 squared. X, instead of negative x, by the time we square it, it's still going to give us a positive x squared. But if I plug in a negative x, instead of minus 10x, I'm going to get plus 10x. The only difference, if the graphs have the same shape but are reflected about the y-axis, the only difference is it's also the difference of f of x and f of negative x.
So really, those two touch.
Yeah, they'll intersect somewhere.
It'll make like a W.
Now,
I see what you're talking about.
finish up here real quick.
Green.
No,
Yellow.
no,
Red,
Seth,
I
it's
said
not
red.
fair.
Yes, you did.
I said yellow.
Because
I
you
won.
because
These two graphs are reflected about the y-axis. If I have the same graph except down here,
X-axis.
this blue parabola is reflected about the x-axis from this one.
Yeah.
No, I don't like this. And just to kind of make the point that this.
I don't care. Kite.
Okay. These two graphs are reflections of
I
each
love
other
it.
about the
I love
y-axis. These two graphs are reflections of each other about the y-axis. These two graphs are reflections about the x-axis. The x-axis is our hinge that we mirror across. These two graphs are reflections about the x-axis from each other.
That's what on my head is saying.
And so that's reflections, and we will cover translations tomorrow.